Hello students, we're going to be looking at section 6.5 in your book, which is on rhombi and squares. These are the guided notes to go over it. So let's first look at the objectives that we're going to be doing in this particular section. So the first one is to recognize and apply properties of rhombi and squares. And then the second objective is to determine whether quadrilaterals, so four-sided figures, to determine whether they are rectangles, rhombi, or squares. All right, rhombi is the plural of rhombus. You can also say rhombuses. Either of those are acceptable and correct. All right, the definition of a rhombus is a specific type of parallelogram with all four sides being congruent. Okay, so it's a type of parallelogram with all four sides being congruent to each other. Okay, let's look at the diagonals of a rhombus. There are two. We're going to be looking at things that are specific to a rhombus. So the first one is that if a parallelogram sorry about that. So if a parallelogram is a rhombus, then its diagonals are perpendicular. So if a parallelogram is a rhombus, then its diagonals are perpendicular. And here's a drawing of that and an example. So if we have parallelogram A, B, C, D, and then it has these diagonals. Whoops, why is that not working right? Alright, sorry, that's just not drawing correctly, so my drawing may not be great, but it will be what it is. And that is a right angle. I'm sorry, so if it's a rhombus, I said this backward. If it's a rhombus, if ABCD is a rhombus, then AC is perpendicular to BD. So that if a parallelogram is a rhombus, then its diagonals are perpendicular, and that's always the case for all rhombi. Second, theorem 6.16, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So if we have this rhombus down here, N, P, Q, R, and it has diagonals. And if we were to start numbering these, like that's 1, 2, 3, 4, 5, 6, 7, 8. What we're saying is that if NP QR is a rhombus, then all those angles that were bisected by the diagonals, those are going to be congruent. So we would say angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Angle 5 is congruent to angle 6. And angle 7 is congruent to angle 8. So everything will end up being congruent to each other. All right. Now let's take a look at squares. The definition of a square is a parallelogram that has 4 congruent sides and 4 right angles. Okay, so this is a real important piece here, that it has both of those things. So the "and" is super important here, that it's got the 4 congruent sides and the 4 right angles. And we talked about this before when we did our original Venn diagrams, but we'll briefly talk about it again. So we know that a rectangle is a parallelogram with 4 right angles, and a rhombus is a parallelogram with 4 congruent sides. So therefore, a square is a parallelogram that is both a rectangle and a rhombus. So it is both. So if we were to have a Venn diagram where this overall big circle or big oval is the parallelograms, and all parallelograms, their opposite sides are parallel. That's what makes it a parallelogram. Then over on the left, we would say these could be our rectangles. And that means for a rectangle, the 4 angles are 90. And then over here, we could have our rhombi. And what that means is that 4 sides, sorry, I can't get it to write. That all 4 sides are congruent. And so then what we would have in the middle here is the square, because it has the 4 angles that are 90 and the 4 sides that are congruent. It's got both. Okay? Okay, now we're going to look at a couple of theorems that are basically the converses of the first two that we talked about, proving that quadrilaterals or rhombi are squares. So if we don't know it in advance, what are the things we can know to say it's for sure a rhombus or a square? 6.17, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus, and that's a converse of theorem 6.15. So in this situation, we don't know that it's a rhombus. We just have a parallelogram, and we know that its diagonals are perpendicular. Then we can say it's a rhombus. So here's a drawing of it, and how we would write that is if JL is perpendicular to KM, then JKLM is a rhombus. We can say that. And now it could potentially also be a square, because this would be true for a square as well. What we would need to know is if J, K, L, and M were all 90-degree angles. So if J, K, L, and M were also 90-degree angles, then it would actually be a square. But this idea can apply to both things. But we're going to specifically talk about a rhombus here. 6.18, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So this is the converse of that earlier one about all the angles. So if we labeled them all, 1, 2, 3, 4, 5, 6, 7, 8, what we're saying this time is, hey, if all of these angles that have a diagonal going through them, so angle 1, if it's congruent to angle 2, and if angle 3 is congruent to angle 4, angle 5 is congruent to angle 6, and angle 7 is congruent to angle 8. So if you have a parallelogram where that's the case, where these diagonals have been drawn and all these angles have actually been bisected, then you can say it's a rhombus. And let's see, that was W, X, Y, Z. So then we can say W, X, Y, Z is a rhombus. Okay, our final two theorems. 6.19 tells us if one pair of consecutive sides of a parallelogram are congruent, the parallelogram is a rhombus. So we have a parallelogram ABCD, and so what we're saying is if side AB, if that is congruent to side BC, then ABCD is a rhombus. Now, where people might get confused about this with the kite, right? Because the definition of a kite is that it has consecutive sides that are congruent. However, we have to remember a kite is not a parallelogram. Okay, a kite is not a parallelogram, so that's why this theorem doesn't work for a kite, because kites aren't parallelograms, and this theorem is about consecutive sides on a parallelogram. Okay, and then finally we have if a quadrilateral is both a rectangle and a rhombus, then it's a square. So if it's a rectangle and a rhombus, if it's both of those things, then it's a square, and that's what we talked about with the Venn diagram. Okay, go ahead and watch the second video that will walk you through a couple of the practice problems. Have a good night.